Hello, I hope you are doing well. I am doing great. Thanks for asking. In this video, we are going to go over this example from the Ambiorix documentation. And it's basically building a small API that has two endpoints. One that lists all the datasets in the bizarre datasets package, and two, the other endpoint will retrieve the said datasets. The point won't be to just go over this code. It will be to write it from scratch ourselves. And now the key takeaway from this video will be when and why you should use request parameters. And number two, we will read loads and loads of R documentation. So this is just us going over these R docs. If this sounds exciting to you, I hope that you code along. So let's get to the terminal and let's create a folder to house our project. So we'll just call it datasets. Very creative. Then we'll cd into that folder. Now we are inside of the folder called datasets. Let's create a file called server.r since we are building a JSON data API. And now for this part, you can ignore I'm just splitting my screen. So tmax new session, I'll call it datasets. And then I will open this in NeoVim. You can open the folder in your favorite IDE. So now I am inside of server.r, and then before we write the program, first of all, let's check if we have the latest version of Ambiorix. So I'm just going to open a new R session on the side, and I will do remotes, then install remotes install GitHub, and the repo will be Ambiorix web, /Ambiorix. So if I do that, you can see that for me, I already have the latest version. So remotes just skips the installation of Ambiorix. But for you, if you don't have that latest version, then of course the installation will proceed. Now, let's focus on the hello world program. So of course, the first thing is to do library Ambiorix, because that is the library that we're using. And then the next thing, let's create a handler for requests @/ right? So let's call it homeGet. It will be a function of request and response. Well, all handlers in Ambiorix take two arguments, the request object and the response object. So it will be a function of request and response, and then the response itself will be, in this case, let's use a list, and let's have it return a code of 200, the HTTP success code, and then we will also return a message, and we will just do hello world. That is the response. Now we need to send it back to the client. Since this is a JSON data API, we will send it back in JSON format. So we will do res subset JSON and then the response, right? The handler is complete. Now we go on to create an instance of an Ambiorix application. So Ambiorix with a capital A and then subset new. Then let's run the application on port 5000. After that, let's attach the handler. So we will say all get requests @ will be handled by homeGet. After attaching the handler, let's start the API. So subset start. And now that is our hello world program. Let's take it for a spin run. So I'm just going to split my terminal again, and I will do R script server.r. If we run that, now this is running on 5000, and since this is just a simple get request, we'll just use curl to test whether it's working. So I'm just going to do curl, and I want you to curl http / 127.0.0.1. This is on port 5000. So this should just return that JSON API, and not the JSON API response. And here we go. So it's in JSON format, and the code is 200 message hello world. So that's working, right? You can of course test this in Postman, whichever client that you want. It's just that for this project, I honestly nowadays I just prefer curl. Done. Now let's move forward with the next thing. We said that we are first going to explore why and when you might need to use request parameters. There is a better way for me to show you that than to just raw dog some code until you understand why. So here we go. Let's say the client tells you that they need a way to access the iris dataset. So you come back to the code and you write a handler for iris get, right? Like to get the iris dataset. So we are going to call it iris get, and this will be a function of request and response. And then the response will be a list. And inside of this list, we will have code 200. And then let's have the message. In this case, let's go with success, and the data will be iris. That is the response, and let's send it in JSON format. So res subset JSON, and then the response. We have the handler. It's time to attach it. So we come here and say all get requests to /data/iris should be handled by iris get. We have created the handler and now we have attached it, meaning if we start our application again, so if we do r script server.r and we try to access /data/iris, then that means we should get the iris dataset in the response. So again, let's do this using curl. So we're just going to do curl and then http //127.0.0.1 port 5000, but this time let's go to /data/API, no, /data/iris, and there you go. So this is like the JSON representation of the iris dataset. And if we just scroll upwards a bit, I can just scroll upwards. Okay, it's a bit, but you can see that the first thing was the code, of course. Then we had the message of success, and then now the third item in the object, in the JSON data object, is the data, which is of course the JSON representation of the iris dataset. Now that is working, but now the client comes back and tells you, we also need the faithful dataset. Can you please make an endpoint for it? Like we need to access it. So you come back to the code again and you create a handler called faithful get, which is a function of request and response. So request and response, and then the response will be a list, of course, the code 200 and the message success. And then the data in this case will be faithful. We have the response. Let's send it back in JSON format, right? The handler is complete. Let's attach it. So any get request to /data/faithful should be handled by faithful get. That's it. Now, if we run this API and someone visits /data/faithful, should be able to access that faithful dataset. And let's test it. So again, we are going to do curl, but now instead of /data/iris, let's do /data/faithful. Okay, failed to connect to 127 port 5000. Is the server running? Oh, I didn't run the server. Okay, so let's do r script server.r. Okay, so it's now up and running. Now if we try to rerun this, here we go. So now if I can scroll just upwards again, you can see that the first thing, of course, again is the code, then we have the message, and finally we have the data item, which now contains the JSON representation of the faithful dataset or data frame, same thing. Now that is working. The client comes back and tells you, you know what? I also need to access empty cars. Can you please create an endpoint for it? So you go back to the code and you create a handler called empty cars get, which is a function of request and response. And then you create the response is going to be a list. Okay, let me, if I can get this right. So it's going to be a list, and then code 200, the message success, and then the data in this case will be empty cars, right? And after that, we send it back to the client in JSON format. So res subset JSON response. The handler is complete and we attach it. So any get request to /data/empty cars should be handled by empty cars get. Yep. So that is, so we have added the empty cars handler and we have attached that handler to the app instance. Let's stop the application and start it again. Then now, if we try to test it, if we do curl and then to /data/, now instead of faithful, let's go with empty cars. And there you go, it's still working. Now guess what? The client comes back and tells you, I actually want all the datasets in the datasets R package. So you fire up your R session and you try to check how many datasets are there in like this datasets package. So datasets : and then press tab, and they are a lot. They like, I think they are around 104 if I'm not wrong, 104 thereabout. You have two options. Either you can create endpoints for all of them and just return them, or number two, you can use query parameters, right? Not query parameters, request parameters. So instead of having all, instead of defining like any get request to /data/empty cars will be handled by this specific handler, you come and say any get request to /data and then the name of the dataset. So not the colon before the name. So any get request to /data/ the name of that dataset should be handled by dataget, for example. So we haven't created dataget yet, but that's where we are going. So I will remove all those handlers and then I'll also remove them because we no longer need them. So we will create this data get handler. It will be a function of request and response. And the first thing that we need to do is to get the name of the dataset that has been passed, right? And to do that, dataset name, it will be the request subset params, and then now inside of those parameters we want to get the name, because remember that is what we have here, like /data/ the name. So whatever will be passed as the name, we can now access it under request subset params subset name. So let's first of all return just the dataset name, the dataset name, to see if we are getting this right. So we'll just say that the response will be a list, then the code will be 200 and the message will be success. And then after that, let's just say the data will be the dataset name for now. And let's send this back in JSON format. So res subset JSON response. After that, let's take it for a spin run. So R script server.r, it's up and running. We now test it using curl. So for example, if we try curl at http blah 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 port 5000 /data/empty cars, this should just return like the data object with a string called empty cars. Yes, so code 200, message success, and then the data empty cars. And if we try running that with faithful, again we should get like the data in this case will be faithful, and it can be anything. So you can actually do something that is non-existent for now. So if you do something, you can see that it will just like return anything that you pass as the name, right? Now after that, let's do what? Let's now access the dataset itself, because now we have the name but not the real dataset. To do that, we'll first have a look at a function called get. So we'll fire up like an R session and then look at the docs of get. Get returns the value of a named object. And the description is search by name for an object, which is get, like in this case, that's for get, or 0 or more objects, that's mget. We are interested only in get. So thing is, of course, to see what is this environment or position, right? So let's see. So and position comma environment, it's where to look for the object, then they're telling you to see the details. If omitted, such as if the name of the object appeared unquoted in an expression. For us, we'll just go with this first line for the object. Let's now go and see the details. So we scroll down and here we go. The position argument can specify the environment in which to look for the object in any of the several ways. As a positive integer, the position in the search list, not as a character string, as a character string, what? As a character of an element, again, in the search list, or as an environment, including sys.frame, blah, 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 blah. Now our focus is actually, because we have the character string, right? So that is our focus. And now the thing that we need to think about is, what is this search list? So we go to the console and let's call search. When we call search, something interesting pops up. Well, env is the first one in this list, followed by package stats, followed by graphics, jar devices, all the way to package base, right? Let's have a look at what is like the docs of search. From the docs of search, you can see that it gives give search path for our objects, and then the description is gives a list of attached packages, and then it's telling you to see library and our objects, usually data frames. The return value is a character vector starting with .global env and ending with package base, which is R's base package, and it's required always, right? So I think at least now we understand what the search path is. So this is like when you define a variable. Let's say we have x subset 10. This is in our global environment. So when we refer to x, for example, if I just press enter, R searches through all these to get the value of x. So it starts with the global env. In this case, it gets x in that global env and returns it. But assuming it didn't find x here, it would then go ahead and search in the package stats, search in graphics, all the way till it gets to the base package, and then it searches in an empty env. Of course, it's empty, so it's not going to find anything there. And finally, it tells you that this object is not found. For example, if I just say xy, you can see that this tells me that object xy is not found. For R to at this decision, it went through all this search list and then determined that, oh wait, I can't find this object anywhere. So now let's go back to the docs of get. And get is saying, let's go to the position argument can specify the environment in which to look for the object in any of the several ways. And then our focus was on the as a character string name, as a character of an element in the search list. Now we already know the elements in the search list. You're going to ask me, but if I just do get iris, this is going to work. And sure, yeah, it's going to work. And I will show you why I don't need that and that I need to specify the environment. Actually, why not just show you now, right? let's not specify the environment. And here we'll just say that the data will be, I want you to get the X will be request subset params subset name, like the past name, the name that is passed by the client. And then we are just going to pass that data here, right? And we are now going to go back to curl and try calling something like faithful. This should just, oh, I didn't start the API. Oh god. Okay, let's start it. So r script server.r, then we'll go to curl and try calling faithful. This works as expected. And if we change that to iris, should still work as expected. If we change that to, I don't know, something like tooth growth, still works, right? But now what happens if I want to, let's go back to the code and let's see what happens if we say X come and save as 10, and then we go back, we restart the API. So let's just stop it and then restart it. Then we go back to curl and note this. What if a malicious user just says X, right? So /data/X, what happens? You see that the value, this is not a data set, right? It's definitely not in data sets, like the data sets are packaged, but a value is returned for it. And this can be like a huge security risk because someone can probably access your env vars this way. What you need to do is to tell get to get like this object that I'm referring to from this specific environment, and if it doesn't find it there, then it should probably just throw an error. It will be totally fine. So let's go back to the docs of get. So fire up another session and then we go back to the docs of get, and let's see. So we already know like what the environment will be. Let's run search again. In this case, we are interested in where is it, datasets, in this one. So like package : datasets. So if we do get, then X will be iris, and then the environment. So the environment, let's set it to, not sure if this will work. I guess I should have just gone with position, but let's try. Package datasets. Yeah, that won't work. Let's go with position. I think position should work. Yeah, there we go. So in this case, we are telling get search for iris, but only in this environment. Now we go back to the docs of get and we see that it has an extra argument called inherits, which is by default true. Let's scroll down and see what is inherits. Inherits states that should the enclosing frames of the environment be searched. We don't want them to be searched, so that means get iris position will be data like package datasets, but then I don't want you to search the enclosing environments, the frames. So we set inherits to false, and so works totally fine. So let's improve. We go back and we say, yes, I want you to get whatever this object is, like whatever the user is requesting. The position will be package datasets, and then let's set inherits to false. So this is a big improvement because now we are assured that even if a malicious user tries accessing a dataset that isn't there, but the focus is on like environment variables, then of course that won't result in like anything catastrophic, right? Let's try it. So let's first of all run the API. I'm going to stop this. Let's do r script server.r. Then we go back to curl and let's start with something that works. So faithful, there we go, faithful is working. Now let's try something that doesn't work and see what happens. X, we get a 500 and it's an internal server error. Go back to the console and we can see that in this case we are getting object X not found as the error. Let's stop this, go back to R and go back to the docs of get, see what happens. So okay, actually let's start with like on the console. If we try to get something that doesn't exist, we get an error. In our case, what we need is, I want you to try and get this thing. If it doesn't exist, can you have a default, as in default to something? In our case, null would be a good default, because then in our API endpoint, we would just check, is the fetched dataset null? If so, then that means whatever you're trying to access doesn't exist, right? Let's go back to the docs of get, scroll down a little bit, continue. The see also section, it states, I want you to see also exists for checking whether an object exists, get 0 for an efficient way of both checking existence and getting an object. Now that is exactly what we need. So we go to the docs of get 0. So both exist and get 0 are documented in one place. So is an object defined? The description is look for an R object of the given name and possibly return it. And when you look at get 0, it takes the same arguments, well, similar arguments to get. So this shouldn't be any problem to us. So it means if we try to do get 0, and then we set X, I want you to try iris, and the environment, let's set it to package datasets, right? Okay, so invalid environment argument. So that means for get 0, it explicitly requires the envir to be like an environment. First of all, let's have a look at as environment. So as environment is a generic function for coercing an R object to an environment. A number or a character string is converted to the corresponding environment on the search path. So the usage is of course as environment X, and then X is an R object to convert. If it's on environment, return it. If it's a positive number, return the environment corresponding to that position on the search list. If -1, then the environment it is called from. If it's a character string, match the string to the names on the search list. And that is exactly what we need. So let's try as environment. Then on the search list, first of all, let's see, what do you have on the search list? We have all this. Our focus is of course on the package colon datasets. So that means we can do as environment and then package datasets. Let's see if this works. It works. And that is exactly what we need. So let's say this is the env, right? And now if we check the class of env, it's of course an environment. Now let's call get 0. So get 0 X is iris, like the string iris, and then the environment, the envir, will be env in our case. And then of course we have to set that an argument inherits equals to false. This works, right? Let's go back to the docs of get 0 and see get 0 has an extra argument here called if not found, and that is what we were after, right? If not found, the return value of get 0 when X doesn't exist, and by default it's null, so it's perfect. So if we try to call get 0 with X is like XY, of course there is no such data set, and then the environment is env, and then inherits as false. Now we get null instead of an error. Again, let's iterate. So now we switch get to get 0, and then we have the X, and instead of the position, let's go with envir environment, and let's wrap this in as environment that, and then of course this other argument stays the same, inherits false. Let's well, start the API. So ask r script server.r, and now if we call it like something that doesn't exist, this shouldn't give us an internal server error. It should actually didn't handle that case. Well, it shouldn't give an error, but it should just give an empty object if I'm not wrong. Yes, so like code message, and then the data is just like an empty array. But in our case, we want to change the code and the message when the data set isn't found. So we go back and we iterate even more. So the first thing we are going to do, so that is the data set, and then by default, this is the response. Then we will say if is null data, what do I want you to do? I want you to set the response, subset the code to 400. Like that is a client error. It's not an error on our side. It's just that the client didn't like provide an existing data set. Well, data set name. And then we will set the response subset the message to data invalid. Let's go with invalid dataset name. That sounds good. And then for the response object itself, like res, we'll now set the status. So res subset status, we will set it to 400. And that's it. So like by default, I want you to like have 200 success and then data. But then if that data set is null, what I want you to do is have the response code, the response subset code is 400, set the message to invalid dataset name, and then set the status of the response object itself to 400. And then of course, finally, we want to return that. So that looks good. Let's stop this and rerun it. We go back and we call it. Now using X, you can see that, now we get 400 and then the invalid dataset name, and then we have the data is just like an empty array, and that is literally what we want for that case. So lots of documentation reading, but we are getting there. So now we can comfortably serve requests for any data set, right? So if the client requests for iris, for faithful, for empty cars, we just have a single endpoint to handle all that. Now the next thing will be to create links in case the client visits slash datasets, and this will be datasets get. So this will just be like a list. Let's actually check in the example. Datasets get should be a list of well, an array of objects containing item, title, and endpoint. And then the item is of course the dataset name. The title is the title, well, of the dataset, and then the endpoint is telling the client if you visit this endpoint, you will of course find that dataset, right? So we go back, and the first thing to ask ourselves is how do we list all the datasets in the datasets R package? So first of all, let's create datasets get. This will be a function of request and response. And of course, now the first thing is how do we list the datasets? Like how do we get the list of all the datasets in the datasets R package? Let's go back to the R console, and let's have 10, right? Wait, actually, before we define the 10, let's just do ls. So there's nothing. What if we do x? We like assign 10 to x, then we do ls. So this is the way to list the objects defined in an environment. In this case, the global environment. Let's have a look at the docs of ls. List objects, of course, and then ls and objects return a vector of character strings giving the names of objects in the specified environment. When invoked with no argument, at the top level prompt, ls shows what datasets and functions a user has defined, as in the global env. And then when invoked with no argument inside of a function, ls returns the names of the function's local variables. And this is useful in conjunction with browser. So you can see that ls has similar arguments to like what we've seen before. So it takes a name, position, environment, and blah, 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 blah. Our interest is probably just on the name and the position. So let's scroll. The name, which environment to use in listing the available objects. And by default, it's the current environment, right? Although called name for back compatibility, in fact, this argument can specify the environment in any form. See the details section. Let's go to the details. Here we are. The name argument can specify the environment from which names are taken in one search list. We have seen the search list before as the character string name of an element in the search list. Now we have everything that we need. So that means first of all, let's again see the search. So our interest, of course, is this one, like package datasets. So if I want to get everything that is exported from the datasets package, well, of course, the datasets, we'll just have to do ls, and then for the name, we will give it package, because name takes like a string. So package datasets, and this should work. There we go. It actually does. So the first part is figured out. So here, let's just call them the names. So nms will be, I want you to ls, and then the name will be package datasets. The first part is figured out. Now let's and of course how to construct the endpoints. Let's first of all construct the endpoints, because we already have like the dataset names, right? So the endpoints will be, let's use sprintf. So sprintf, and we are going to do, if you send a request to http://127.0.0.1 port 5000, and then /%s, which will be like the dataset name. So for %s, we'll pass in nms, right? So like sprintf http 127.0.0.1, then the port, and then /data I had missed that. So /data/ the dataset name. So if you visit this endpoint, you should be able to get that said dataset. Now we have the endpoints. Now the next thing is, of course, to get the titles. How do we get the titles? Again, let's go back and check the docs of data. So :data, and here we are. Loads specified datasets or lists the available datasets. And then we check on the usage. So we have data takes ... and then list package. So that means, could it be possible for this package, like for this data function, to list all the datasets in a package? So let's have a look at this package argument. Here we are. So package is a character vector giving the packages to look in for data, for datasets or null. By default, all packages in the search path are used. Then the data subdirectory, if present, of the current working directory, blah, blah, blah. We're not interested in that. We're just interested in this first sentence. So that means I can do data and the package. I'm just going to say datasets. This gives us something. What if I assign this to, let's say, X for now, right? And what is the class of X? The class of X is package IQR. Okay. What are the name, or let's start with the mode. So the mode of X is a list. That means it could have names. So what are the names of X? So it has title, header, results, and footer. Okay. Let's get the title. So X subset title, datasets, X subset header, nothing, X subset results. This looks like what we want. Let's take the first few observations. So head. So you can see that X subset results has the package, of course, datasets, the lib path, the path to the library, then it has the item. So in this case, the item is similar to what we have as an NMS on our API endpoint, as in it's similar to this NMS, right? Okay, let's go back. So that is the item, but you can see that this item has, some of them have spaces and they are not sorted. For example, chiquit comes after CO2, but in our case, NMS, this NMS that we got from LS is sorted. And to know that it's sorted, let's have a look again at the docs of LS. LS has an argument called sorted, which is set to true by default. And when you look at sorted, it's a logical indicating if the resulting character should be sorted alphabetically. That means for these results, we need to sort them by the item alphabetically, right? And then after that, we can of course match the title to now our NMS. So what do we do? First things first, let's just set it to a data frame. So X subset results and then S data.frame. Then I'm just going to assign this to X again. And after that, let's reorder the rows by item in ascending order. Of course, we are going to use the order function, and you can see that order returns a permutation which rearranges its first argument into ascending or descending order, breaking ties by further arguments. If you look at order, it takes dot dot dot, which is a sequence of numeric, complex, character, logical vectors, all of the same length, blah, blah, blah. Basically, what you want to order. And na.last, it has decreasing to false by default, meaning it's ascending by default, right? That is what we need. And maybe to just show you how it works, say we have y, which is let's say 3, 1, and 2. Actually, yeah, 3, 1, and 2, right? If we say order y, this returns indices. These are indices and not the values. Actually, maybe let's make y a bit more obvious. Let's use z, maybe k, and maybe m. If we say order y, you see now it returns 2, 3, and 1. These are the indices in that y vector, like that y character vector, right? So if we say y subset order y, now this should return y in an ordered format. Yes, so we start from k, m, and then finally z. Yes, so that is how order works, and it's what we want for our x. So what we do is we say x subset, I want you to order x subset item, and it should be in increasing order, so I don't care about like setting that decreasing argument. So I want you to order x subset item. That is, now we are taking x, I want you to subset this, like this new order of rows, and then currently we don't need anything for the column, so we'll leave it blank. And let's take the head of this and see what it has. So you can see that now, this is ordered. So it starts with ability.cov, air miles, air passengers, blah, blah, blah. What now we need is to subset this title and match them to NMS. And that's literally it. So we go back to our endpoint and do all that we just said. So where to start? First of all, we need to get that data. So we are going to say data, and then the package will be datasets, right? This is going to be an object which you can get the results from. After getting the results, we'll convert this to a data frame as data.frame, and then we will assign this to, let's just call it data. Now after that, we need to sort this data by the item column. So we will do data subset. I want you to order data subset item, and then after that, in this case now, I need the title column, so I'm just going to get it. Actually, yeah, I'm just going to get it. Let me do it afterwards. So whatever you give me, I want you to subset title. Now they will be in the same order as NMS, and this is the titles actually. So now we have the names, we have the endpoints, then we have the data. No, we don't need the data. Then we have the titles. So the response will be a list code 200. So code 200, and then the message will be success. Then the data sets in this, data sets will be a list which will contain the, let's just go with the names. So we have item, title, and endpoint. Okay. So the item will be NMS, then the title will be titles, and then the, what was that other one? Endpoint. The endpoint will be endpoints. That is the response. Looks like I have a typo on this. That's the response. Let's send it back to the client in JSON format. I could have a bug or two here, but let's hope that it works. So I'm just going to restart the API. So R script server.r. It's now running. Now we go back to, well, curl, and this time we want to curl. Did we attach the handler? We just oh yeah, we already attached it like the very first time. Okay. So in this time, we want to make a get request to /datasets. And there we go. This is actually amazing. So if we can just scroll upwards a little bit, you see that now the code 200, the message is success, and then the datasets, we have an item called ability.cov, air miles. Now that I think about it, is this really what I want? Because my thinking was, I have the item and its title on the same object and not on different arrays. That means I have to go back to the code and do something here. Maybe I think what I need is to just convert this to a data frame. It should work well. So data.frame. So data.frame, we set the item, the title, and the endpoint. This should give us what we want. So I'll stop and start the server again. Then we'll go back to curl and we will make that request. Okay, let's inspect this. If I just scroll upwards a bit to the start. Okay, here we go. So you can see this time we have the code, the message, and then for the data set, like now this is more palatable. So for the first object, we have the item is ability cov, the title is ability and intelligence test, and then this is the endpoint, right? Actually, something to note is that since this like when you visit these endpoints, by default, we are just dealing with get request currently, and that is the default for browsers too. If you visit this in your browser, it should be able to give you something. So for example, if I can just copy this, and if I go to my browser and paste that, oops, I meant not paste it with the quotes. So you see that we get like a representation of that that JSON. And the same, like if we replace ability.cov with something like faithful, same thing happens. We can as well go for cars. Yes. So you can see, since browsers make a get request by default, our server handles this well. Yes. So I think, sorry. So I think we have completed all the set milestones for this video. Where, why, and when you should use request parameters. We have read lots of documentation, and then we have this datasets get endpoint for getting all the datasets, their name, their endpoint, and their title. So thank you for watching, and you have a great day.